Hello everyone. Today we're gonna see a presentation about firewall. This presentation is gonna be presented by me, Hamza EL MASSOUDI, and Isaam ASSIYADI. In this presentation, we're gonna see an introduction to firewalls. Why are they essential? The types of firewalls, use case for firewall solution, and comparison between the use case. And we're finally gonna see a quick demo of how to set up PFsense. So we're gonna move. First of all, let's begin with the definition of a firewall. A firewall is a network security system that monitors and controls traffic based on a set of predefined rules. You can think of it as a gatekeeper for your network, allowing only trusted data in and keeping potentially harmful traffic out. It creates a protective barrier between trusted internal system and untrusted external networks such as the internet. Firewalls plays a several critical roles in a network security. Here are some of the key functions. A firewall inspects all the incoming and outgoing traffic, ensuring only safe and authorized data passes through. Firewall helps prevent threats like hacking, malware, or ransomware from reaching your internal systems. By dividing networks into smaller segments, firewall help limit access and isolate threats, improving overall security. Why firewalls are essential? In today's digital world, cyber threats are constantly evolving. Firewalls act as the first line of defense against cyber attacks like hacking, malware, or ransomware. They block unauthorized access and ensures that your systems are not compromised. Many industries are required to follow strict regulations such as the GDPR, HAPAA. Firewalls play a key role in meeting these standards by securing sensitive data and in ensuring that only legitimate user can access critical system. Firewall carefully filters all of the traffic entering or exiting a network. They allow only legitimate traffic while blocking unauthorized or suspicious requests. For example, a firewall can be configured to block access to malicious website or stop unrecognized traffic from reaching the system. Finally, firewalls also enable secure remote access for employees or users working outside the network using virtual private network capabilities. A firewall ensures that remote users can securely connect to the organization's system without risking exposure to cyber threats. So on this slide, I'll highlight key benefits of using firewalls to secure networks. First of all, monitoring and filtering network traffic. Firewalls constantly monitor all network traffic. They filter out malicious or suspicious activity and only allow authorized traffic to pass, ensuring that your system remains completely safe. Preventing virus infiltration. By inspecting packets and identifying potential threats, firewall help prevent viruses, malware, and other harmful software from infiltrating your network. Blocking unauthorized access. Firewalls serve as a barrier blocking any unauthorized access attempts from hackers or malicious users. This protects sensitive systems and data from being compromised. Upholding data privacy. Firewalls ensure that sensitive data is protected and prevent leaks. By monitoring data flow, they safeguard critical information from being accessed by external threats. Finally, firewall help organizations comply with the regulatory standards such as GDPR. By enforcing security policies, firewalls ensure that businesses meet this necessary cyber security requirement.
A package filtering firewall is one of the most basic type of firewalls that operate at network layer. It works by inspecting individual packages of data and applying rules based on information like source IP address, destination IP address, port number, and protocol type. If a package meets the rules, it either forwarded or blocked. Well, package filtering firewall are simple, fast, cost-effective, and they lack of deep applications capabilities, such as analyzing package content or content states, connection state. They are best suited for basic security implementation, but may not effectively protect against advanced attacks.
A stateful inspection firewall enhanced capabilities of package filtering by keeping track of state of active connections. Operating at transport layer, it monitored entire connection lifecycle, ensuring that all the packages related to legitimate established connection are allowed through. For example, if an ongoing request is made, all the expected incoming response will be permitted. This method provides better security than package filtering alone, as it can prevent unauthorized access attempt. However, inspection firewall can consume more resources on large network, make them slightly less effective for high traffic environments. A proxy firewall, also known as application level gateway, works as an intermediary between the user and external network. Operating in the application layer, it inspects and filters traffic based on a specific application protocol, such as HTTP, like there in the example, FTP and DNS. Instead of allowing direct communication between a client and server, the proxy firewall forward request on behalf of the client, masking the internal network identity, and these deep inspection capabilities make proxy firewall ideal for preventing advanced threats and filtering malicious content. However, they can introduce latency and require more processing power compared to other firewall types. A next generation firewall is an advanced security solution that combines traditional firewall features with additional capabilities like deep packet inspection, intrusion prevention system, and application layer filtering. Next generation firewall operate across multiple OSI layers from network to application, providing a comprehensive visibility and control over network traffic. They can identify and block advanced threats such malware, ransomware, and application layer attacks. Using signature based on and behavior analysis, next generation firewall are crucial for modern security architecture, offering robust protection in enterprise environment, but they tend to be resource intensive and more expensive than traditional firewalls. A web application firewall is a specialized firewall that focuses on protecting web applications by filtering and monitoring HTTP and HTTPS traffic. Operating at the application layer, web application firewall are designed to protect web services from common threats like SQL injections, cross-site scripting, and cross-site request forgery. They analyze web traffic in real time and block malicious requests that could exploit the vulnerabilities in web application. So that make web application firewall crucial for organization hosting web-based services, but they are limited to protecting only web applications, not the broader network infrastructure. A software firewall is installed on individual device, such a desktop, server, or a laptop, to filter and control traffic to and from those systems. It provides endpoint level protection by monitoring application and blocking unauthorized accesses. Software firewall are easy to deploy and configure, make them a popular choice for a personal computer and small networks. However, they can consume system resources and may not scale well for a large enterprise networks. Example include Windows Firewall for Windows system and IP table for Linux system. A hardware firewall is a dedicated physical device designed to monitor and filter incoming and outgoing traffic in a network. placed on a network perimeter. Hardware firewall operate independently of servers and provide a high-speed, reduced security for large network. They are ideal for enterprise environment where performance and centralized traffic management are crucial. So, a hardware firewall offer advanced features like VPN support and deep packet inspection. However, they can be costly and require specialized knowledge to configure and maintain them properly.
Moving to the next part. In this part, we're gonna see use cases for firewall solutions. We're gonna start with Cisco Adaptive Security Appliance. Cisco or Cisco ASA. Cisco ASA serves as a stateful firewall offering robust security by monitoring and controlling the flow of network traffic. The ASA firewall operates as a stateful firewall, meaning it not only evaluates individual packets based on predefined roles, but also tracks the state of active connection. How it works. It inspects packets at all the layers up to 7 for application level security. Only packets that belong to an established trusted session are allowed to pass through. For example, if a user sends an HTTP request, the ESA allows the response traffic to return, but unsolicited traffic is blocked. ASA uses ACLs to filter traffic based on roles set by administrators. These roles define which packets are allowed or denied based on source IP and destination IP, ports, and protocol. Cisco ASA extends traditional packet filtering by inspecting traffic at the application layer. ASA can analyze specific protocols like HTTP, DNS, FTP, and SIP to detect and block application-specific threats. This prevents attackers from hiding malicious activities within legitimate login application traffic. ESA integrates not for secure handling of IP addresses. It converts private IP addresses to public ones, shielding internal system from the direct exposure to external network. It allows multiple devices to share single public API, improving security and response usage. Cisco ASA provides traditional and application-aware firewall capabilities, but for deeper protection, it is often complemented by next-generation capabilities provided by solutions like Cisco Firepower Services or Cisco Secure Firewall Threat Defense. Next generation firewall offers deeper application level visibility, advanced threat detection, and integration within modern security tools. And here are some of the key models of Cisco ASA. We have 5500X series, commonly used in enterprise for scalable security. ASA 1000V, a virtual version designed for cloud and virtualized environment. ASA with Firepower Services combines ASA firewall capabilities with advanced threat detection and prevention. So let's see this example where we try to connect three networks with the internet configuration. This network setup uses a Cisco ACA device to serve as a security gateway between the internal network and the external internet. The internet network is represented by the address 10.2.1.0 with a mask of 24. Subnets are interconnected by two routers, router A and router B. The Cisco ASA device is strategically positioned between the internal network and the external network or the internet. It has two logical interfaces: the inside interface, which connects to the internet network, and the outside interface, which connects to HTTP router that serves as the gateway to the broader internet. The Cisco ASA acts as a firewall, controlling and monitoring the flow of the traffic between the internet and external environment. This setup helps protect the internet resources from unauthorized access or threats originating from the internet, enhancing the overall security of the organization's network infrastructure. The specific configuration details, such as firewall roles and routing protocols, are not explicitly shown in the diagram, but this high-level topology demonstrates how the Cisco ASA can be integrated into a network to provide a secure and controlled access between points and between the internet and external network. Moving on to the next use case, we have the PFsense. But PFsense is the one we're gonna do. Isaam is gonna do a demo with in the end. So PFsense is an open source enterprise grade firewall and router software based on FreeBSD. It can be installed on physical hardware, virtual machine, or as a cloud-based firewall. PFsense provides a comprehensive set of network security features, including stateful packet filtering, VPN capabilities, intrusion detection and prevention system through tools like Snort, load balancing, traffic shaping, and advanced monitoring tools. Its a web-based interface allows for easy configuration and management, making it accessible to users of all skill levels. PFSense is a cost-effective alternative to commercial firewalls like Cisco ASA, offering robust performance, scalability, and flexibility for small businesses, enterprises, and home networks. We're gonna do an example. And lastly, we have Fortinet FortiGate. Fortinet FortiGate is a next generation firewall that provides comprehensive network security solution for enterprise and businesses of all sizes. It combines stateful firewalling with advanced features such as intrusion prevention systems, application control, web filtering, advanced threat protection, and virtual private network capabilities. FortiGate uses FortiOS, Fortinet's proprietary operating system, to deliver high performance threat detection and prevention while offering deeper visibility into network traffic. So lastly, we're gonna do a comparison between the use case of the firewall solutions. So we have the Cisco ACA is positioned as a high cost enterprise grade option with moderate ease of use and customization capabilities. It offers advanced security features, making it well suited for a large organization and enterprises. In contrast, PFSense is low-cost open source firewall solution that is highly customizable, but it has limited advanced security function. It is considered ideal option for startups and small to medium-sized businesses that require flexible and cost-effective network security solutions. Fortinet's FortiGate firewall sits in the middle with medium to high cost and moderate ease of use and customization. It provides advanced security features similar to Cisco ACA, making it suitable choice for small to medium sized businesses and that require robust security capabilities. The choice among these three options will depend on specific requirements, budget, and technical expertise of the organization, as well as the desired level of security. Right, so in the next part, we're gonna see a quick demo on how to set up PFSense with Isaam.
Now let's dive into the demo and explore its powerful PFSense firewall. To keep this demo short and focus on showcasing a key feature of PFSense, we have already installed and pre-configured it. So let's go ahead and launch the two virtual machines. We have there a CyberOps virtual machine. We will use it to configure our and manage our firewall, and PFSense virtual machine. Let's launch it now. So as we can see there, we will wait until the PFSense initialize and work properly. So and let's launch also the CyberOps virtual machine. Where to configure our firewall will use PFsense web interface, which is hosted on the LAN interface. There we can see wait until PFsense initialized. Now it is off. It's work properly. Now let's go to configure it via the web interface. We'll launch CyberOps virtual machine, and we will go to the LAN and web interface. We have already pre-configured. We will see here in the dashboard many information about our firewall, his name, CPU usage. So we will go to create a row. Let's create a row on the LAN interface that block ECMP, the ping requests. So we will go to firewall roles and we will go to LAN interface. Then we will add a new row. So we make sure that we action is both. As we can see here, there is the difference between block and widget. So we will change the protocol to ECMP is the ping request, and the source is our LAN. So we will shows LAN sub address. So destination is in it. Before save it, we will test first. We will test our ping. We will ping into Google. As we see there, the ping is we received the response from the Google successfully. Now let's save the role and then apply its changes and see what will happen. So let's send another thing to the same website as Google, and as we can see there here, nothing we receive nothing from the Google. If we stop the ping, we will receive that all packet is lost. So we will send again and to double check. Again, nothing is received, and we will see again that all packets is lost.